Alrighty, so this video is going to take you through some worked examples dealing with distance versus displacement. So remember, distance is the total length that an object is traveling while they are moving. Displacement only cares about the distance between their starting point and their finishing point. So let's go ahead and take a look at this graph here. We have 4 different scenarios that we're going to go through. On the bottom, we have a number line that tells us how many meters of distance. I'm just guessing that it's meters. Notice that the scale goes by twos, so we're going to have to do a little bit of estimating where like 1, 3, 5, whatever meters, okay? So we're going to go through each one of these and calculate the distance and displacement. So let's take a look at A. What is the distance traveled by object A? So in order to calculate the distance, again, we're looking at the entire length that this object has traveled. So it is starting at 0 meters and it is traveling until 7 meters. So we would say that the distance they traveled is 7 meters. If we're looking at the displacement, we're looking at specifically the starting and the ending points. Train your brain. I always start when I look at displacement by looking at the final position first, and then the initial position, and then all I have to do is subtract. So for A, the final position is at 7 meters. The initial position is at 0. So all I have to do is go 7 minus 0 is 7. So the displacement of object A is 7 meters. Now, this is a scenario where the distance and the displacement happen to be the same, and you're going to run into that. It could be that distance and displacement are the same. There's also scenarios where they aren't going to be the same. Let's take a look at this one. So object B, what is the distance being traveled by object B? Notice that its starting position is at 12 meters. Its final position is at 7. So you just kind of have to figure out what is that distance. And if you're like me, I still kind of count on my fingers. So like 7, 8, 9, 10, 11, 12. They traveled 5 meters. Now, distance is always going to be a positive number, right? It's just a total amount of the length that's being traveled. So 5 meters, it's good, even though we know B was traveling in a opposite direction, in a reverse or backwards direction. When we go to calculate the displacement, that's where we're going to see a change. So again, displacement, train your brain. Final position was 7 minus the initial position, 12, which gives us a negative 5 meters. It's okay for displacement to be a negative number. That negative sign only tells us that that object ended up in a position that was behind or backwards or to the left of where they had started. Okay, so the negative sign, leave it, don't delete it. It's important. It tells us direction. Okay, let's do part C. This is where things get just a little bit trickier. So C is the red line, and notice that it's got like this little zigzaggy loop here. Let's kind of like talk through the story of point C. So it started at 2 meters. It traveled in the forwards direction until 10 meters. Then it turned around and went backwards to the 8 meter mark, turned around again, and then went forwards and ended up at the 10 meter mark. Okay. Now, the total distance being traveled, we have to add together each of those little intervals. So the first one from 2 to 10, that's 8 meters that object traveled. Then we add together the fact that it traveled 2 meters backwards, and then we add 2 meters going forwards. So 8 plus 2 plus 2 gives us a total distance of 12 meters that object traveled. The displacement, though, remember, we only care about the starting and the final position. Train your brain. The final position was 10 meters. The starting position was 2. 10 minus 2 is 8, and this is a positive 8. So that tells us that that object ended up at a position to the right of or ahead of where they started. How far away? 8 meters away. So in a situation like this, you have to think to yourself, okay, so even though object C was like moving around and zigzagging back and forth a little bit, displacement, they started at 2 and they ended at 10. So they were displaced 8 meters. Even though they had a bunch of zigzags in between, they were displaced 8 meters. All right, let's do the last one. So the last one is object D. Object D starts at 9 meters. It traveled backwards to 3 meters, and then it turned around and traveled forward until it got to the 5-meter mark. So the total distance traveled, we have to calculate this first chunk going from 9 to 3. That's 6 meters plus 2 meters going forwards. So that's a total distance traveled of 8 meters. The displacement, again, is the final minus the initial position. So it ended at 5 meters. Then we subtract 9 meters. So it was displaced -4 meters. Again, that negative sign is important, so you need to keep it in there. The negative sign tells us that object D was displaced to the left of or behind where it originally started. If you need to rewind this video, rewatch it, ask questions. Otherwise, the next few slides are going to be some practice problems for you guys.